Ever since we figured out that we cannot resist the advance of time, the idea of doing just that has been a topic of significant thought. From the time machine to the TARDIS, we seem to love the idea of mucking about with time. Despite this interest, for quite a while we've thought of time travel as a mere fantasy, impossible in reality. Recent information, however, would appear to dispute this idea. I'm Eric Rhodes, and I'm going to tell you why one can time travel, and how. As was previously stated, time travel has been commonly accepted as impossible for quite some time now, with the theory of relativity having put the final nail in the coffin. Before even this, however, was the problem of paradox. Let's say that we have our time traveler, Joe, and he decides to go back in time and kill his grandfather, before he had met his grandmother. So Joe hops in his generic time travel booth and goes back. Joe gets out and shoots his grandfather dead. Now what happens? Since he died before he could, Joe's grandfather never conceived his father. So Joe was never born. Joe wasn't born, so he couldn't have gone back and killed his grandfather. Meaning the grandfather lives, which means that Joe lives, which means that he kills his grandfather. This is why we can't have nice things. This is an example of a paradox, a logical failing, and all-around bad situation. The trick of a paradox is that it literally can't happen. It just breaks the laws of logic. Where paradox put the time travel idea into question, however, the theory of relativity pretty much killed it. The theory of relativity, among many other brilliant things, relates time and space. The faster that you go through one, the slower that you go through the other. This means that as you approach the speed of light, time itself slows down. At the speed of light, in fact, time seems to stop. This actually confirms the possibility of forward time travel. This is a phenomenon known as time dilation, and has been quite well observed. Unfortunately, it's pretty much a one-way trip. To go back in time through raw speed requires beating the speed of light in a vacuum. For the curious, doing this requires in excess of infinite energy. So, no. It would appear that time travel is dead on arrival, but solutions exist for both of these problems. For example, you can't beat light in a vacuum, but if you don't have to, your method is still legitimate. Paradox, on the other hand, is a slightly trickier subject to beat, but it is still solved through the Novikov self-consistency principle. The principle takes the idea of multiple possibilities coexisting from quantum theory and applies it to the past. In short, what we don't know about history is still in flux. All possible states are coexisting if we do not know otherwise. On the other hand, what we do know is fixed, and it cannot be successfully changed. This means that Joe would not be able to successfully kill his grandfather. After this failure, if Joe decided he wanted to go save Amelia Earhart with his time machine, he could just pick her up in the middle of her famous flight. Because we do not know what happened to Earhart, with no wreckage or body found, it is a possibility, however slight, that she was picked up by a dashing time traveler such as Joe. While time travel is apparently possible, it's rather unlikely that it will be done in a generic time travel booth. Rather, there are several possible means to time travel. The most likely means for a young civilization to achieve time travel is through the use of an Alcubierre drive. This is a remarkable means for cheating the law of relativity, which allows for faster-than-light travel with finite amounts of energy. Essentially, the drive bends local space-time in such a manner that it is always falling forward, with no maximum speed. The law of relativity is preserved because light starting in the bubble of warped space will still beat the drive. If this Alcubierre drive were used to escape a black hole after orbiting within the event horizon, the result would be backward time travel. The Alcubierre drive looks like a pretty sweet deal, except that finite is a rather large range of numbers. The best estimates of energy needed for a working drive is the mass energy of about 700 kilograms. In case you aren't near a calculator, this is approximately the world energy usage in 2008. It might be a minute. Further in the realm of advanced technology is the wormhole device. This would use two wormholes, essentially a shortcut through normal space, and accelerate one to near the speed of light. Thanks to the time dilation effect from our old frenemy relativity, the wormholes will now provide a means to go between the two time frames as well as the places. For example, if we made the holes on New Year's Day of 2015 and sent one off in a spaceship which was approaching the speed of light, we could go through the one here on Earth and exit the other one in its own time frame. Even if 100 years have passed on Earth, we could go through the hole and end up in the spaceship and the year 2015. The main problem with the wormholes is that they tend not to be stable or large in the theories which include them, and we don't have the means to get a ship up to relativistic speeds. Doing so would require nearly as much energy as the Alcubierre drive. The ultimate in time travel, however, the creme de la creme, would be the use of cosmic strings. A cosmic string is essentially a one-dimensional fracture in the fabric of space-time. These strings were formed during the rapid expansion of the early universe, in much the same way as a flaw forms in a rapidly expanding crystal. A cosmic string has immense mass, over 1 Earth mass per kilometer, yet nearly 0 thickness. The length of a cosmic string dwarfs galaxy clusters, some of the largest scales of organization which we have seen in the cosmos. But what really makes these structures interesting in terms of their time travel applications is that if two of these strings could be set to oscillate about each other, each oscillation would produce a new closed time-like loop. Essentially, it would be like a new snapshot of the universe is made each time the strings oscillate. Using a simple maneuver near the strings, simply going around them in a circle, would allow one to move between these snapshots with ease. This means that potential time travelers could go forward or back in time as they please, but only to times after the oscillation began. There aren't any snapshots to go to before that. The main problem here would be the doing of it. Cosmic strings are, by their nature, rather difficult to move, and getting two of them to oscillate with each other would truly be a Herculean task. Time travel is certainly possible, there's no doubt about that. Forward time travel has been quite conclusively proven through time dilation. Backward time travel even can quite easily be proven. The question is if it is feasible, and to that the answer is a very firm maybe. Even the lowliest of methods given here are far beyond humanity's current reach. For a grander civilization, however, in a grander age, with technology that can't even be imagined by humans, time travel wouldn't be science fiction at all. It would merely be science.